In this video, we're going to take you through a bit of problem solving. We're going to look at how we can use the mole concept to solve for a range of problems in this section which we call mass-to-mass stoichiometry. Stoichiometry looks at a quantitative relationship that exists between reactants and products. And we know about this relationship based on a balanced chemical equation. This balanced equation allows us to work out how much of a reactant might be needed to form a particular amount of product. It might allow us to work out the amount of reactant that's needed to completely react with a different reactant, or it can be used to predict how much product will be formed when a certain quantity of reactants are combined. To get you thinking about this, we're going to talk about making some pancakes. So let's just imagine that our recipe for making pancakes is quite simple. What we need is 1 cup of flour. We also need a couple eggs, so 2 eggs. We will also need a bit of baking powder as well, 1 teaspoon there. And let's just imagine we mix these ingredients together, and this allows us to produce 5 pancakes. If we think of a slightly different scenario, now we've got a larger number of pancakes that we want to make, so perhaps we have a bigger family, and we need to think about how many eggs we might need to make 20 pancakes. And just remember, in our previous example, in order to make 5 pancakes, we need 2 eggs. So in this case, we would need, you can imagine, 4 lots. So 4 lots of 2, which give us 8 eggs. So here we go, we've got our 8 eggs here, and we would know that this is needed to make 20 pancakes. We could do the same thing by looking at the amount of teaspoons of baking powder, how many cups of flour as well. So hopefully this allows you to see how we can link this into a balanced equation. So this one here, it shows you the reaction of nitrogen and hydrogen to produce ammonia. It's one of the most important reactions known to man. We manufacture ammonia using this reaction in a process called the Haber process. So by looking at this balanced equation, what we can see is that 1 molecule of nitrogen as a gas can react with 3 molecules of hydrogen as a gas to produce 2 molecules of ammonia as a gas. These coefficients allow us to work out the number of reactants and products needed to form a particular amount of product. And instead of just talking about molecules of reactants and products, we're now going to talk about moles of reactants and products. So we can say that 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. This just summarizes what we've just mentioned. So in terms of molecules, we could even look at extending that. So 100 molecules we would expect needs 3 times the amount of hydrogen molecules, and that will produce 200 molecules of our product. And like I said here, we really want to talk about the use of moles of reactants and products. And this will give us a way to calculate some information that may be necessary. This shows you the rules and the process to solve any question that uses what we call mass-to-mass stoichiometry. The general situation is that we have the mass of a reactant or a product that is known to us. So we might measure the amount of a reactant, or we might know the amount of product that gets formed. And we need to use that to work out the mass of either a reactant or product that is unknown to us. If we have a look at these rules, we just follow 4 relatively straightforward rules. First thing that we normally do is record all the information that's provided. The second step is we look at any information that we know. We determine what we call the N known. That's the number of moles of our known, and we use a formula that links moles to mass. Step 3, we use what we call mole ratios, and we use this to determine the number of moles of our unknown. Finally, we calculate the mass of our unknown, and we use a rearrangement of the mole formula, which is this here, and its mass is equal to the number of moles multiplied by the molar mass. Our first example here, we've got 1.05 grams of aluminium being burned in XX oxygen to produce aluminium oxide. We need to determine the mass of aluminium oxide that is produced from this reaction, and we can only use this information that's given to us here. So let's look at how we can break this down into those 4 steps. We've got our balanced equation here again, and we need to record all the information that's provided. So we know the mass of the aluminium over this side. It doesn't matter what the mass of oxygen is, we're just going to assume that enough oxygen was needed, was added to completely react with this aluminium. We're concerned with trying to work out the mass of aluminium oxide. And you may have guessed it by looking at those formulae that we will need to know the molar masses of these reactants and products. So I've got the molar masses here. So aluminium, we just read from our periodic table, it's 26.98 grams per mole. And to calculate the molar mass for aluminium oxide, we just have to consider for 1 unit of aluminium oxide, we would need 2 lots of aluminium, and we would add that to 3 lots of oxygen. One very, very important thing, and this is something that students commonly make as mistakes, is they include this 2. So this 2 is what we call the coefficient. It's what we need to balance the equation. Students tend to use this when they calculate the molar mass. And I'll repeat this, but you need to make sure that you don't include this number when you calculate the molar mass. Okay? Don't include this number when you calculate the molar mass. When we do work out what the molar mass for this is, we end up getting a value of 101.96 grams per mole, and you can go ahead and check that yourself. I've now just represented what my known is and what my unknown is. This will make a lot more sense when we look at the next step. So determine the number of moles of known using this formula here, so mass divided by molar mass. If we look at what information we've got the mass and we've got the molar mass, so we'll go ahead and substitute these values in. We're working out the number of moles of aluminium, so we substitute those values in, put it into our calculator, and this is approximately the number that we get. I've put in some asterisks here just to keep this answer in your calculator. The most important thing that we do is ensure that this fully correct answer stays in our calculator, and we don't round off any of our answers until we get to the very end of our question. Just keep in mind, we're trying to work out the mass of aluminium oxide. The third step is to use mole ratios to determine the number of moles of our unknown. So how do we do that? It's essentially based on our balanced equation. So this was our balanced equation here. We can see 4 moles of aluminium react with 3 moles of oxygen, and they produce 2 moles of aluminium oxide. We can represent this mole ratio as a fraction, and this fraction I would like for you to represent it as the number of moles of unknown divided by the number of moles of your known. Our unknown is aluminium oxide, our known is aluminium. And if we just take those coefficients at the start of the chemical formulae, we have 2 over 4. This then allows us to rearrange the equation to then solve for the number of moles of aluminium oxide. Keep in mind that we calculated this in the second step. So we now will get the number of moles of aluminium oxide equal to 2 over 4 times by the number of moles of aluminium. We know that 2 over 4 is equal to a half, or 0.5. So we just multiply that to our answer in our calculator that we obtain in step 2. And again, I've just rounded this off for the purpose of not making the numbers too long, but we have 0.0196 approximately moles of aluminium oxide. Just don't forget to keep this answer in your calculator. We're going to use it for the very next step. So this fourth and final step, we need to calculate the mass of our unknown, and we're going to use this formula here. Just remember that we calculated the molar mass of aluminium oxide already. So we're going to go ahead and use that. We've got the mass of aluminium equal to the number of moles times the molar mass. We've got our number of moles calculated in step 3, our molar mass which was calculated in step 1. So we now just take our answer in our calculator, we then times by the molar mass, and we end up with a number of 1.98 grams. And just keep in mind, I've rounded off here to 3 significant figures, and that's because in our original information, we got given the mass of aluminium as 3 significant figures. Just for a second example, we're going to use the same reaction, but this time I've told you how much of our product has been formed. 3.605 grams of aluminium oxide is formed during a reaction between aluminium and oxygen gas. We need to then determine the mass of aluminium that's needed, and I've put in here in brackets, given all the aluminium reacted in excess oxygen. That just means we've got plenty of oxygen to allow the aluminium to react. We're going to go through this in exactly the same way, using the same 4 steps. So record all the information provided. We're going to start off with our balanced equation, and we can see the ratios, the mole ratios of our reactants and products. And these are the coefficients at the front. So we want to work out the mass of aluminium. We have the mass of our product. We're going to go ahead and reuse those molar masses that we calculated before. Aluminium at 26.98, and then aluminium oxide is going to give us 101.96 grams per mole. I'm then going to just label these as my known and unknown. So in this case, my known is my aluminium oxide product. My unknown is my reactant aluminium. So from here, we'll take it to the second step. We need to work out the number of moles of our known. We just use this formula mass over molar mass. So substitute our values in that we've got here. The mass is 3.605, molar mass 101.96, and we get an answer of approximately 0.03536. Again, just keep that answer in your calculator, use it for the next step. Step 3, we now need to use mole ratios to determine the number of moles of our unknown. So this is going to use those coefficients in the balanced equation. Our unknown is going to be aluminium. Our known, we already know, is aluminium oxide. So what we can see now is this ratio is, or in other words, this fraction is the other way around. So it's now 4/2, which is equal to 2. We're going to rearrange that, and we're going to get the number of moles of aluminium equal to 4/2 times the number of moles of aluminium oxide. So we go ahead and we multiply our previous answer by 2, and we end up getting 0.07071 mole approximately. Again, still keep this in your calculator. We're going to use this in the last step, which is to calculate the mass of our unknown, and we're just going to use this formula. So here we go. The mass of aluminium is equal to the moles times the molar mass. We've got our moles from part 3. Our molar mass for aluminium is 26.98, and we get an answer of 1.908 grams, and that's recorded to 4 significant figures. If you like this video, be sure to like and subscribe to my channel. Thanks for watching, and I'll see you guys next time.